Hello there, aspirants. I hope all of you are doing perfectly well. So, in today's lecture, we're going to be talking about the Heisenberg's equation of motion in Schrodinger picture, which is a very important theorem in quantum mechanics because lots of questions are usually asked. Just like I can tell you, the Unfist theorem or the virial theorem is basically derived from this Heisenberg's equation of motion. So today we're going to see that how to prove the Heisenberg's equation of motion. So just let me write it down. H SENBERG, Heisenberg's equation of motion. Tell me, how will we prove it? So basically we know two things very clearly. The first one is expectation value of any operator A cap in the state psi at time t. The expectation value of any operator A cap in state psi of t is defined as psi of t is defined as expectation value of A that is actually equals to integration psi that is actually equals to psi of t A cap psi of t, and then you can write divided by psi of t. If I take that this thing is actually normalized, the state is normalized, the expectation value of any operator A cap in a normalized state, in a normalized state psi of t, in a normalized state psi of t is defined as like this. The state is normalized, so psi of t will be equals to 1, so this becomes equals to psi of t A cap psi of t. That's in bracket notation. ये bracket notation में है, but अगर इसी चीज को मुझे लिखना है wave function notation में, तो मैं इसे कैसे लिखूंगा भाई लोग? I can write it as integration all space psi star of x comma t A cap psi of x comma t, right? Or if I'm just writing it down in the 3 dimensions, so you can just write r comma t r के ऊपर वेक्टर r comma t dq bar, which is actually equals to dv. I can write it like this. There is one more thing which is needed to be considered, that is, we know IH cut, time independent Schrodinger equation, partial differentiation of psi of x comma t with respect to t is actually equals to h cap psi of x comma t in wave function notation. In wave function notation. Therefore, if I take dagger of this equation, it will become minus I h cut minus I h cut partial differentiation of t psi star of x comma t क्योंकि dagger of a scalar is always complex conjugate with respect to t becomes equals to h cap psi whole dagger it will actually show you h cap psi whole dagger h cap psi of x comma t whole dagger that is psi star of x comma t h cap simply because h cap is Hermitian because h cap is Hermitian because h cap dagger is h cap because we all know that h cap dagger is equals to your h cap. It's Hermitian operator, we all know, so it will look like this. Now we can go to prove the equation of motion in terms of Heisenberg. And how will we prove it? We can prove it in a different ways basically, but the most important way we can prove it is just to write down the equations one by like you can just write down the Heisenberg's equation of motion by that if you want. So let me just show you how will we do it. Let me just show you how will we do it. ddt of expectation value of A at time t is basically equals to psi of t a cap psi of t into ddt of psi of t a cap psi of t, and then this can be written as ddt of integration psi star of x comma t a cap psi of x comma t, not x, rather it would be better if I just write down r vector. In 3D, I think 3D would be rather better. I shouldn't just bring it on one dimension. Let's just write down the equation in 3D, so it will become r everywhere. It will be r, brother. Good. It will be r. It will be r everywhere, psi of r comma t. Good, everywhere it is r. Good. So you can see this equation is r comma t, this d cube r. So on the next line I can just bring this total differentiation inside this integral sign, but see inside the integration it's a function of r and t, both the spatial variable and the temporal variable. So when the total differentiation gets inside the integration, it becomes what? It becomes just partial differential equation. Because here it is a function of both the variables. When total differentiation gets inside the integration, it becomes a function of both the variable psi. So it will just partially differentiate psi with respect to only t. So I can just write the equation in the form like integration. This will be equals to partial differentiation of psi star with respect to t, partial differentiation of psi star with respect to t, psi star of r vector comma t with respect to t a cap, and then we can write down this psi of r comma t, psi of r vector comma t into d cube r, plus I have to do the differentiation of this again, integration psi star of r vector comma t d a, no, it will become partial differentiation of a cap with respect to t actually, and you will see psi of r vector comma t d cube r, and then again plus integration. I have to do the differentiation of this one. So psi star of r vector, psi star of r vector comma t a cap, partial differentiation of t psi of r vector comma t dq bar. That's all I can write. Now you can tell me what to write in place of partial differentiation of psi star. Partial differentiation of psi star can be written as negative of 1 by I h cut psi star h cap. So negative of 1 divided by I h cut, I can write here simply psi star h cap a cap psi into dq bar. Of course, I'm just not writing this function. You know that it is this into dq bar integration. Plus here I can write integration psi star partial differentiation of a with respect to t and then psi into dq bar, plus this one will become integration psi star a cap. What can you write in place of partial differentiation of psi with respect to t? Partial differentiation of psi with respect to t can be written as 1 by I h cut h cap psi. 1 by I h cut 1 by I h cut h cap psi into dq bar. Then of course you all know what you can do. Just take these two things, common 1 by I h cut. You're gonna get 1 by I h cut. If I take common, I'm gonna get integration psi star. Here it is a h minus here it is h a, then psi, then dq bar. Well, of course, you know that AH minus HA is basically the commutator between A and H, and this is basically an expectation formula. Plus this thing I can very well write down as an expectation value of partial differentiation of A cap with respect to T. On the next line, this one becomes 1 by IH cut. This one can be very well written as expectation of commutator of A, comma H plus A with respect to T. Done. So 1 by IH cut, expectation of commutator of A comma H plus partial differentiation of A with respect to T expectation. So this is basically Heisenberg equation of motion. So these are the prerequisites which are necessary. And here, this thing I can write. Okay, one more thing that I might be tempted to write down sometimes. Size of R vector comma T can be written as simply psi. That thing I can do, and psi is equal to 1. That was mentioned, so this thing happened. Psi I mean psi of t is equals to 1. So this is normalized, and psi of rt can be written as simply psi. So don't worry about that. And this is the entire reality of expectation value of A with respect to t is this thing. So I hope there is no doubt in this proof, because it's just the Schrodinger equation time independent, and from where I have derived two equations. This is the Schrodinger equation. I have taken the dagger of this equation, I got this one. और इन दोनों रिजल्ट को यूज करके हमने इसका प्रूफ किया. ठीक है. So it's a very important equation, और इसके रेस्पेक्ट पे तुम आर्नफेस्ट थ्योरम प्रूव कर सकते हो, तुम विरियल थ्योरम प्रूव कर सकते हो, और CSIR NET में बहुत सारे क्वेश्चंस आते हैं फ्रॉम आर्नफेस्ट थ्योरम एंड विरियल थ्योरम. So I hope this will be helpful for all of you. If you have any doubt, do let us know in the comment section. We will revert you back. ठीक है. Thank you very much. मिलते हैं नेक्स्ट सेक्शन में. Bye.